Hello, everybody. How's the volume? Good? Good? Well, thank you all very much for coming. My name is Seth Art, and I'm going to be talking about exploiting cross-domain XML files today. Like many of you, I've been playing with computers for as long as I can remember. That's me. Currently, I'm an associate at Blue Canopy and a member of Nova Hackers and also OWASP DC. So the purpose of this talk is to introduce you to the cross-domain XML file if you haven't heard of it, to hopefully convince you to start looking for it on all of your web application assessments, and lastly, to show you how to exploit this vulnerability when you find it. So I'm sure some of you are familiar with same origin policy, but I wanted to cover it at the top really quickly anyway. So same origin policy restricts how a document or script loaded on one origin can interact with a resource from another origin. So basically that's saying if you have one browser window open, you have two tabs. On one tab you have mail.google.com, you're authenticated. On the other tab you have bsidesdc.org. There's no code that can be loaded into your browser from bsidesdc.org that can interact with your authenticated session at mail.google.com. That is a control that's enforced by the browser, and it's called same origin policy. So what is the cross-domain XML file? Well, let me explain it this way. If a SWF is embedded in site A, or a SWF, aka a flash object, is embedded at site A, and it tries to load data from site B, the Flash player will disallow this cross-domain request by default. And that should sound a lot like same origin policy because Flash has its own same origin policy. However, with Flash, site B can grant site A access to its data through the use of a cross-domain policy file. And that is the cross-domain XML. So think of it as a way for site B to specify who it trusts. And this is an example of a properly configured cross-domain.xml file. So what we're looking for here is the allow access from directive, and specifically the domains that are the domain or domains that are being trusted. So in this case, this policy file allows me to make the following statement. Any SWFs loaded into a user's browser from Macromedia, Adobe, Photoshop, and Acrobat.com are authorized to make cross-domain requests to www.adobe.com. And this is an example of what could be an overly permissive cross-domain XML file. This is the most permissive policy that you can have. And again, we're looking at the allow access from, but in this case, the domain equals star. So SWFs loaded from anywhere can interact with intranet-web server. For those of you who are familiar with application security, think of exploitation of this vulnerability as somewhere in between cross-site request forgery and cross-site scripting. Cross-site request forgery, because in every instance of exploiting this vulnerability, you are making the victim make a request on your behalf. However, unlike normal cross-site request forgery where you can make the victim make the request, but you can't see what comes back, it's a blind request. But with this vulnerability, similar to cross-site scripting, you can see the data that comes back. And lastly, I wanted to touch on the fact that this is a server-side vulnerability. Specifically, it's a misconfiguration of that cross-domain.xml file on the server. However, it's the client or the users of that vulnerable server that are being exploited. And to illustrate that point, I wanted to use these graphics here. So there's three players that are required for exploitation. The vulnerable server, the malicious server, and the victim. And the evil SWF is hosted at the malicious server. And I wanted to highlight that at no point does the malicious server make any direct connections to the vulnerable server. When I was first reading about this vulnerability, especially when you read about the SWF making a cross-domain request, I got stuck on this, so I wanted to make this very clear. The victim is always required for exploitation, which is a client-side attack. So the first requirement is that the victim needs to be authenticated with the vulnerable server or have restricted access to the vulnerable server. The next requirement is that the victim needs to arrive somehow at the malicious server. So think phishing, watering hole attack, something like that. Once the victim arrives at the malicious server and they download the evil SWF, that SWF is now executing in Flash Player, which is inside of the browser, running in the context of the browser. Now, the author of the SWF can code the SWF to make any cross-domain request that the author chooses. It's up to Flash Player and that same origin policy to determine whether those requests are actually allowed to be made. And the way that the mechanism for doing that, for asking permission, is the cross-domain XML file. Flash Player makes a request to the vulnerable server, and as you can see here, this vulnerable server says allow access from domain equals star. So Flash Player says, I have a SWF from malicious.com. Is it authorized to talk with you? And this server is saying, yes, I don't care where it's from, it's authorized to talk with me and access my data. So once the victim has been authorized, or that evil SWF has been authorized to interact with that domain, it can now make the request that is encoded, and this is the response coming back. So that's something that normally shouldn't happen. The evil SWF has made a request to vulnerable.com. This is the data coming back, and this is the data being sent back to the attacker. So before I move on from this vulnerable server and the allow access from domain equals star, I wanted to kind of frame this a little better with just some points. So I think a lot of people get stuck on this at first too. The site is still vulnerable even if it doesn't use Flash. Think about it this way. Any site that you control, if you were to put a cross-domain XML file at the root and it was overly permissive and there's sensitive information on that site is now vulnerable to this attack. And second, the cross-domain XML applies to the fully qualified domain name. So if there are multiple applications sharing the same FQDN and one application team drops the cross-domain XML that's overly permissive, they've just affected the confidentiality of both applications and the integrity of both applications. And lastly, keep in mind that everywhere you see a domain equals star for the allow access from directive does not necessarily mean there's risk. Think about a public site with nothing but public information. We call those brochureware sites. And it's just telling you about the institution. There's no sensitive information. So there's nothing worth stealing, and there's no actions that are worth C-surfing, so there's no risk, even if SWFs loaded from anywhere can interact with them. And a good example of all of those last couple of points is www.capital1360.com. So as you can see, www has a wide open cross-domain XML file. However, all of the sensitive information happens at secure.capital1360.com, and there is no cross-domain XML file at that FQDN, which means that it defaults to the same origin policy, which means a SWF can't interact with that at all. So the SWF, you can write a SWF that can interact with www, but it wouldn't get anything, because there's nothing worth stealing. So I just wanted to touch really quickly on a few ways to discover this vulnerability. First is just manually entering it into your browser. Once I started doing this research, I kind of got in the habit of everywhere I went, I just typed crossdomain.xml, and you're looking for the allow access from directive in the domain equals star. The second, a lot of the automated scanners and the manual proxy tools, this is Burp Suite Pro, will alert you if an overly permissive cross-domain file exists. And Nikto also has a specific plugin called Client Access Policy, and it will run. You've probably seen this if you've run all the plugins before. If there is a cross-domain XML file and it contains a wildcard, it'll alert you. So at this point, I wanted to touch on the history of this vulnerability. This is a really old vulnerability. Crossdomain.xml was introduced in 2003 by Flash Player 7. By 2006, Chris Shiflett, Julian Korver, and Jeremiah Grossman were talking about this vulnerability and blogging about it publicly. In fact, in 2008, Jeremiah Grossman released a video showing him exploiting this vulnerability on YouTube. And then in 2010, Erlen Affedel revisited this issue, wrote a bunch of great blog posts, and released the Mallory of Proxy tool as well. So you might ask yourself, why am I at a security conference in 2014 listening to this vulnerability, talk about this vulnerability? And I think this is why. Aside from Jeremiah Grossman's 2008 demonstration of this being exploited, when I started doing this research, there were no other real-world scenarios of how to wrap your head around, number one, how can you exploit the vulnerability, how can the vulnerability be exploited, and more importantly, how can I go from finding the vulnerability to actually exploiting it myself. That just wasn't out there when I first started doing this research. But I'm here today, so what changed? Well, for me, it was this blog post by Gursif Kalra about a year ago. He wrote this blog post, And in that blog post, he released this action script code. It's a single file of action script code, and he explained that you can compile this action script code into a SWF that will exploit this vulnerability. And in fact, all you need to change are the two things highlighted in yellow, and I'll go over those in a little more detail. The thing is, I finally had, I wrapped my head around this vulnerability. I felt like I understood it enough to exploit it, but I didn't have an application that I was testing at work that was vulnerable to this at the time. And I was impatient, so I decided to look around the internet. And I wasn't disappointed. So these are just a few of the sites that I've responsibly disclosed this vulnerability to, and they've since been fixed. So I'll use these in my talk and some of the examples. But there are tons out there. And I would encourage you, if you have any interest, into looking for some of these and responsibly disclosing them. I think what the issue is that unless you can demonstrate the vulnerability and demonstrate the risk, if you just tell a site, well, this configuration is wrong, they might not really understand, and they might say, put up a fight. So the first one that we'll talk about is Bing. And in this demonstration, I'll show how you can exploit this vulnerability to see the search history of everything that your victim has ever searched for while authenticated with Bing. So this was the crossdomain.xml file at www.bing.com. As you can see, the domain =* for the allowances from directory. Now, Bing allows you to query everything you've ever searched for using this URL, ssl.bing.com/profile history. The thing is, there's no cross-domain XML file at SSL. So our SWF can make a request here, but nothing would happen. Flash player would respect the same origin policy and tell you to go away. However, if you enter www.bing.com/profile/history and you're authenticated, you still get your sensitive authenticated search history at www. So combine that with the fact that www is sitting on an overly permissive crossdomain.xml, and we can now write an exploit that will force the victim to browse without them even knowing to www.bing.com/profile/history and send you everything that they've ever searched for. And this is the script, this is the action script code that does that. All I've done is replace the two portions highlighted in yellow. On the top function, you're specifying the target, so where you want the victim to navigate to. And in the bottom function, that's where you're specifying where you want that stolen data to go to. So that's where you send it to your own server. And in this case, I'm sending it to a file on my server called bing-history.php, and that file just writes everything that comes into it onto disk. So once I had my authenticated victim load my SWF, or authenticated with Bing, and then they loaded my SWF, this is the data that is on my attacker box, and as you can see, I'm just parsing this out and looking at everything that they ever searched for. So for my next example, I'll use plentyoffish or POF.com. And a little story about Plenty of Fish before I get into the details of the vulnerability. So if any of you have ever responsibly disclosed a security vulnerability before, you know that the best practice is to send an email to the security @ and support @ email aliases at that organization. Unfortunately, they didn't exist, so they bounced back. The next thing I tried to do was fill out the About Us, Contact Us customer service page on their website. Unfortunately, that was just a black hole. I didn't hear anything back there either. So kind of as a last-ditch effort, I went to careers.pof.com, found a job application, and applied to it with, instead of a cover letter and resume. Now, this was on a Friday afternoon. On Monday morning, I got an email back from the CEO, Marcus Friend of Plenty of Fish, thanking me for the disclosure and telling me he did a little research and he already fixed the vulnerability. I thought that was pretty cool. He also told me that he created a security @ alias for future exposures. Nice guy. So the reason I wanted to talk about this vulnerability, though, is it allows me to talk about a limitation in this vulnerability compared to, say, cross-site scripting. The SWF, your SWF file that you create, your evil SWF, it doesn't have access to the DOM. And it doesn't have access to the HTTP response headers that come back to the victim. All it has access to is the HTTP response body. So unlike cross-site scripting, we can't just default and kind of try to send document.cookie over to us, right? We can steal and hijack the session that way. The thing is, if the application ever writes the value of those cookies into the HTML body, that is fair game for our SWF, and we can make the victim make the request and steal that cookie. And I'll show you that really quickly here. So this is the cookie. This is not touchable by our SWF because it's in the cookie header. And you see the value is highlighted in yellow. But if I can create a SWF that makes a request, that makes the victim make a request to www.pof.com/inbox.aspx, that value shows up in the HTTP response body, or the view source, the source of the HTML. So at this point, we can do just what we did with the Bing example: send the response, the whole response, back to the attacker. At that point, the attacker puts that cookie value into their browser using something like Fire Cookie, and they have now just hijacked the session, even though the Flash player didn't have access to the headers. And that same scenario applies for cross-site scripting. If you have cross-site scripting, but they're using the HTTP only header flag properly, that same scenario applies. Okay, so let's. So this is the next example, Imager. And another little story about Imager. So I sent this disclosure, this email to to Imager at 11:29 p.m. 2 minutes later, I got an email back from Alan Schaff, the founder and CEO, saying that he'd be happy to work with me. Please send him more information. I sent him the proof of concept, and by 12:15 a.m., he wrote me back saying he fixed the vulnerability. They didn't need the overly permissive cross-domain anymore. I thought that was pretty impressive. That's 45-minute response time for the 48th most popular site in the world. So that's a high bar. Also, to Imager's credit, they are protecting against cross-site request forgery using Nonces. And any of you application security people in the room know that Nonces come back. They're a unique value that is created by the server that is sent to the client that an attacker would normally have no way of knowing. Well, that comes back to the client in the HTTP response body, and that now is fair game for our evil SWF. That's why. So now, if you have both vulnerabilities in place, or if they use Nonces, even though they use Nonces, if you have the overly permissive cross-domain XML file, you can still bypass that Nonce defense and execute the cross-site request forgery. So to show you an example of that, Imager has the ability to have public pictures and private pictures. And in this example, the user has all of their album settings set to private. And what we're going to do is we are going to bypass the CSRF defense and make the victim change their album privacy settings to public. So if the victim makes the request themselves to make the privacy settings public, this is that request, and as you can see, highlighted in yellow with the arrow, that's the nonce. So that's the unique token that the attacker normally has no way of knowing. And that's what our ActionScript code is going to do. Our ActionScript example in this POC needs to do 4 things. This is also based on Gursev's POC, but this has been expanded to do the following 4 things. First, it makes the victim make a request to the page that will give the victim the nonce. Then, this portion in blue will extract the nonce and any other dynamic things that it needs to extract to create this URL up here. So once it has all the dynamic pieces, it concatenates that. The dynamic pieces are in yellow, and then the static pieces, the make your album privacy public, that is up top. And so it creates that post request and then sends that out to Imager, and the victim sends that out to Imager, and now the victim has made, without them knowing, has made all of their images public, and the attacker can now see those pictures. So for my last example, I'm going to use ThinkGeek, but this is actually quite common. So in this example, what I'm going to do is I'm going to completely hijack somebody's ThinkGeek account by using CSRF to change the email address on that account. So as you're all familiar with, these days, even if you're authenticated with an application, if you want to change your password, it asks for your current password. That's a great thing. That is another confirmation that a real person is, the person who owns the account is making that change. The thing is, I rarely see an email address field that requires the current password to change the email address. And combine that with a forgot password feature, and you have a hijack scenario. So this, I just wanted to show you, this is highlighted in yellow in the top there. Just the name of my SWF should be self-explanatory at this point. Bypass CSRF, change email address, ThinkGeek. So anybody who is authenticated with ThinkGeek and then goes to my malicious site and loads my SWF, in this example, will have their email address on their account changed to sethsec@gmail.com. At that point, I sweep in and go to the forgot password function, enter my email address, and then the password reset email address for their account comes to me. I can reset that password to whatever I want, and now I own their account until they realize that their password doesn't work anymore. So I'm done with those type of POCs. I just wanted to share with you something I came across, kind of a revelation I had halfway through my research. So this should look a lot like the example at www.adobe.com. There's no domain equals star anywhere in this file. However, this is just a snippet of the crossdomain.xml file at secure.history.com. There are 89 unique domains that are trusted in this file. And this is not uncommon. I mean, that got me to think, what if one of those 89 domains has expired recently and is available for purchase? What if they made a typo, and I definitely saw this, and the domain that they put in their whitelist was not something that they ever owned. It's just been available for as long as they've had that whitelist. So to prove that point, guess who owns cnonstyle.com? So at this point, I own cnonstyle.com, so if I can get somebody who's currently authenticated with secure.history.com, and then they go to cnonstyle.com and load my SWF, it's the same as if it was domain equals star. It's really just a race to who's the first person to purchase that available domain. And so this is another example of a really long one. This is www.sears.com. Actually, since Sears and Kmart were just recently in the news, I also found the same thing. So Sears and Kmart have almost identical cross-domain XML files. And I saw that quite a bit too. So some of these sites that are owned by the same group share similar cross-domain XML files. So I wanted a way to automate the process of looking to see if these domains were available. So it allowed me to create an Nmap script called http-crossdomain. So I have submitted this to Nmap, but it hasn't been reviewed and approved into the project yet. So I'm going to distribute this. I am distributing this in my GitHub project now, but if it ever gets accepted by Nmap, I'll remove it from my GitHub project and it'll just come with Nmap. But the purpose of this script is when you specify a domain, it'll look to see if a cross-domain file exists. And if one does, it will give you two pieces of information. One, the URL to Dynadot, the bulk domain search lookup tool, and two, it'll give you a comma delimited list that now you can copy that list, paste that into the Dynadot bulk domain search page, and if you're lucky, one will be available. So what this means is, if you ever see a crossdomain.xml file, currently right now, Burp and a lot of the other tools will just tell you if there's domain equals star. But really, you need to start looking at every single line in those files for the same vulnerability, just manifested in a different way. And not that I don't trust all of you in this room, but I did purchase SearsTestSite.com. Okay, so now I'm done explaining how this vulnerability can be exploited, and let's move to how you can actually create the exploit. So the GitHub repository is called Cross-Domain Exploitation Framework. It's not much of a framework right now. If I do more research in this area, I wanted to give myself room. But currently, there's a tool called Swift Server, and that will, if it hasn't been run before, it'll install all the prerequisites listed below. And once all those have been met, it just turns itself into a web server that will serve your your Eagle Swift file. So I'll show you that with a demo. And for the demo, we're going to be using Ubiquity's AirVision product. So this is a management application that manages IP cameras, like IP security cameras. And we're going to be using an old version, a vulnerable version, the version that I found these two vulnerabilities on and sent to Ubiquity. This has since been fixed, but for the purpose of showing you the exploit, we'll use the vulnerable version. All right, so there's the AirVision product. So this screen will be the victim on this screen, and then on this screen will be the attacker. So now we are going to execute a cross-site request forgery exploit through our evil SWF that we create. So let me just log in here. And what we're going to do in this example is we're going to create a new administrator. So as you can see, there's only one administrator right now. So and I'm just going to go through A to Z for you. So right now, I'm not going to be the victim. I'm going to be the attacker doing research on how to pull off the cross-site request forgery. So in order to do that, and this is the same process you'd use for exploiting cross-site request forgery, I'm going to actually make a user so I can learn what's required to make a user. Okay, so now I have the victim going through burp, and I just wanted to show you this post request right here. This is what's required to make the user that I just made. So this is the request that we're going to have our evil SWF file send. So what I'm going to do is I'm going to send this to the repeater. And we use test as the attacker, or just learning about it. But just to make it clear, we're going to have the victim create a user called CSRF. We're going to be in the admin group. Okay. And you could do this manually, but since this is a JSON, this is JSON being sent to the server. If we're going to use it in our POC, we're going to need to escape those quotes. So actually, Burp Pro has a really cool tool. I'm just going to use their JavaScript XHR, because you'll see here. See how all of the quotes have a backslash in front of them now? So that's what we're going to put into our ActionScript code in a second. So now let's switch over to the attacker. So all I've done at this point is download the cross-domain exploitation framework from GitHub. And you can see here we have the SWF server. So unfortunately, to create your own SWFs, you need to download a 340 megabyte file from Adobe. I'm serving this locally just to make sure that download will go really quickly. But that'll take some time. And right now, it also takes a little time. It's going to unzip that framework. So Adobe Flex is the compiler. That's the tool that you use to compile ActionScript into SWF files. So once all the prerequisites have been met, it's going to tell you that installation is complete. Please compile a SWF and start the SWF server again. And to do that, we are going to choose a template from ActionScript templates. And as you see here, so this bottom one is pretty much Gersev's POC with just one small change. And that's what you would use anytime you want to steal data, a lot of my first examples. We're going to use CSRF, but I've included the POCs that I've used in ThinkGeek and some of those other sites here where you have to extract the CSRF nonce. They're more advanced. So in interest of time, we're just going to do a very basic CSRF here. And even though we're doing a CSRF instead of just stealing data, it's really only a few things that you need to change. So this is where you set your target. And for that, copy the URL. There we go. And this portion right here is what sets our request to a post. And then this is where we set the post body. So you can see this CSRF example is I added this example based on this exploit here. but we're just going to start from scratch. So remember, I just used this CSRF generator right here to kind of do that encoding for me quickly. That's not a required step. Oh. I learned about the U in BI way too late. That is awesome. Okay, and lastly, this is not required for CSRF, right? For CSRF, you don't require anything to come back to you. But since we have the ability, I'm going to send us, once the victim creates the account for us, I'm just going to send us feedback, the page that the victim gets. And I'm going to send that to this attacker box. I'm just going to use my IP address here. And so so Swift server, when it is a web server, it uses base HTTP server in Python. And I've coded the two methods get and post. So get it'll just serve the file that's being requested. I have post. It's kind of bastardized. Any page that you send a post to, it doesn't matter if the page exists or not. It'll just write that data, that post data, to disk. So we can just call this anything. And at this point, we need to compile the action script and drop it into the web root. And so we're going to call it exploit.swf. It can be named anything, but the way the exploit works is that you first send your victim to an HTML file, and that HTML file sends them to the Swift file. So the HTML file that comes stock with this tool is looking for exploit.swift. So if you give it a different name, just change the HTML file as well. Okay, it's my lucky day. No typos. So that file exists. So now, because that file exists, we can run the Swift server, and now it's no longer doing any installation. It's telling us it's listening on port 443, and it's instructing us to do three things. And remember, this is required for every exploitation of this vulnerability. Number one, your victim has to be authenticated with the site that you're trying to attack. So let's just verify that they still are. Okay, they are. The next thing, convince your victim to arrive at your server. So let's do that. And so my tool uses a self-signed cert that it creates, for you as part of the installation process. Obviously, if you purchased a cert, you wouldn't get this warning here. But for the purpose of showing a developer the vulnerability, this works fine. So this is the stock index page that comes with the framework. This is nice and polite, telling the victim that they are being exploited. You can change that if it needs to be more realistic. And so we should see here. Actually, you know what? Before we look up, a little suspense. So let's look from the attacker's perspective. This is what happened on the attacker's perspective. The attacker saw that the victim 214.1 arrived at the index. The index page then sent them to exploit.swift. The Swift was loaded, and then I know that it was executed because it made that post request to this random string right here, and I'll show you. So what I have it doing is writing a file on disk using the IP address of the client and the time for epoch. So that's how I know it worked, but let's just go verify that right here. And here we see the CSRF administrator. right, so that's how easy it is to go from finding an overly permissive crossdomain.xml file, finding something worth C-surfing, and then creating an exploit. I just think it's pretty cool to see, since we're going through burp, we have the luxury of kind of seeing everything that went on behind the scenes. And so this is what it looked from the victim's perspective. So the victim was sent to index.html. Oh, I'm sorry. Well, yeah. This is the phishing, right? So we phished the victim to index.html. It then loaded the SWF in the victim's browser. Now, this is what we were talking about. This is Flash Player making the request to crossdomain.xml at the vulnerable site. And you can see here the domain equals star. And it's also interesting, keep an eye out for this. If the SWF makes the request, the SWF is in the refer. So from a defensive perspective, you might want to keep an eye out on anything that's initiated from a SWF. And then same thing, this is the actual CSRF payload. Also, the refer will be the SWF. And then this is just the data being sent back out to the attacker. All right, so that's the demo. Okay, so I saw a lot of crossdomain.xml files, and it's not as straightforward. Kind of like what I was saying with cross-site scripting, we don't have access to the DOM, so you have to be creative when exploiting this vulnerability. And I found plenty of crossdomain.xml files that, even though it was vulnerable to the theoretical vulnerability, there were some mitigating factors in place that either allowed me not to be able to pull off the entire attack or not be successful at all. And I wanted to share some of those with you as potentially some defenders in this room. So this first one isn't a defense in depth strategy. This just hits the nail on the head. I mean, be careful who you trust in your crossdomain XML file. Periodically review the list of trusted third parties. Segment your data by subdomain. So this is one that I saw where I have a really big high-profile target. I mean, kind of like Capital One 360, but there are some that I can do quite a bit in one subdomain, but then the thing that I really want to CSRF is behind a different subdomain that doesn't have a cross-domain XML file, and so that's it. I mean, I can't do anything. That segmentation protected that site from exploitation. Now, in terms of purely defense in depth recommendations, require your users to enter the password for any sensitive action required to account settings. So not just changing password, but changing email, changing snail mail address, if that is somehow related to resetting an account. Credit card numbers are taken care of by PCI compliance. I mean, you can't show your users anything more than the last 4 or the first 6 of their credit card number. But take that lesson from PCI compliance to heart and apply that to any other sensitive information. The idea is that I never need to see my credit card number from the website to make an update, right? I have my credit card, I can just re-enter that in. Same thing, whenever that applies, restrict the showing of that information. Secure.history.com, for example, is a good one. I can see my saved credit card. As the attacker, I could see, but I can only see the last 4 numbers, which really mitigated the risk there. And lastly, this is kind of a defense in depth protection for cross-site request forgery. It's not a silver bullet, but combined with Nonces, if you're already using Nonces, check the refer, right? So if you see that the SWF is coming from outside of your domain, it's not going to be called malicious.com, but if you see that it's not originating from your domain, don't allow that request. Or at a minimum, review those refers that are coming from other locations. And to wrap up, although I said that it was Gursev's blog post in 2013 that finally helped me wrap my head around this vulnerability, and actually, a funny story, the first time I had to write this vulnerability up was before that blog post, and then the second time was after. I mean, it's just amazing, just that he was able to share that, and that what we do, sharing information. It became possible for me in that 6 months in between those 2 finds. So although his blog post allowed me to go from A to Z, it was the research and work done by all of these people here and I'll post these slides on GitHub, so please take a look at some of these links. This is some really great stuff. And as you can see, a lot of this applies to a lot of web application concepts, same origin policy, cross-site scripting, cross-site request forgery, etc. So that's it. Any questions? Yes, it's. I was hoping you'd ask that because I didn't want to derail my train of thought in the presentation. That secure at the end is why I'm serving the SWF files on HTTPS. That's all it means. So, I mean, it just adds another step for the attacker. But so if you see if it's just here, let's. Well, if you see the secure at the end, you have to serve your SWF over HTTPS. If you don't, you can serve it over HTTP. Good question. That's a good question. So it definitely knows where it's being loaded from because it won't query the cross-domain. That same origin policy, that's how it does that, right? So if you're loading a SWF, or if you're making requests to the same domain that served the SWF, it never even asks for the cross-domain.xml because it's same origin. But to answer your specific question, it depends on how you're retrieving the SWF. If your cross-site scripting is then changing the location to the third party, it will remember that, you know, I think. But I haven't fully researched that. I mean, that's a good question. They are a good delivery for that phishing type, watering hole type of attack, right? They're a good way to get the user to authenticate or to download the SWF from the evil site. Yeah, but I'm not. Yeah, does that answer your question? Not really. Yeah, that would be another vector to get that person to load the SWF. Yeah. Any other questions? Yes. Oh, it does? Okay, Nikto now will list the domains. Java FX. So I mean, absolutely, yeah, that's a really good point, and that's kind of why I named my framework cross-domain exploitation framework. This same style of attack is possible via Silverlight. Silverlight uses something called client access XML, and then the whole class of these tools are called rich internet applications, RIAs. That's why it's called the malRIA proxy. So all of those that have the ability to do cross-domain requests like that, and they all use this file for trust. Thank you. Any other questions? All right, well, thank you all very much for coming.